I'm from Andes Technology and I'm the head of sales for EMEA, Russia and Japan. Today I want to give an overview about RISC-V and why it's now the right time to make it. Welcome to the RISC-V days in Tokyo. Please enjoy this presentation. Let me start which age we are in. The age we are in can be defined with the age of the domain-specific architecture, where we are adding domain-specific extensions to CPUs to make it more fitting for a certain product. But it's also the age of security. We connect more and more devices to the internet. Everything is 24 hours, 365 days a year, connected to the internet, submitting data, so we need more security. It's also the age of agile hardware development. We cannot take 5 years or more to develop a chip. Chips are developed in shorter and shorter times and are more complex than ever before. And last but not least, it's the age of the open ISA. An open instruction set architecture can speed up things, and that's the times we are in today. Things getting more specific, need more security, get more agile, and we have an open ISA. To make it short, like John Hennessy and David Patterson said, we believe we are in the golden age for computing architecture. A lot of possibilities, a lot of chances. Now, why is RISC-V everywhere? And how can RISC-V be the right thing in the golden age of computing? First thing is that new CPU architectures always need time in the beginning. It needs time to be adapted. You need to have tape outs. It needs to be reviewed. For RISC-V, it's already around many years. We have now over 6 years where it's already from many people pushed. So the designs are already very proven in implementations from industrial or commercial partners. And there are many tape outs by many different companies. RISC-V has a big advantage. With RISC-V, customers can have different use cases. For example, some customers need to adjust for extreme low power IoT devices. Others may do some high data accelerator where the power is not so important. And then RISC-V also allows you, that's what we are seeing, to scale better. So you can have designs with 1 core, with 2 cores, maybe 10 or 30 cores, and it reaches up to many cores. So for example, I have already heard of designs with 1,000 cores and even more. RISC-V, also coming back to this flexibility, gives you more flexibility. You can add domain-specific architectures. That means you can add your custom instructions to allow for greater flexibility and therefore enable true innovations. And last but not least, it's very important to have a good and stable ecosystem like RISC-V has. It takes time to build up an ecosystem, and you're investing in this ecosystem, so you need to make sure it will be around for the next 5, 10, or maybe even 20 years. With the investment in RISC-V, with big multinational companies joining and doing this, we have exactly this guarantee. That will be the instruction set of the future. We're also seeing that RISC-V is now used in the car industry already, so that is a kind of proof that it will be the right choice for you to do. Let's have a look on some of the applications where RISC-V is used. These applications are very typically for RISC-V, and here especially Andes Technology already has customers. For example, in the mobile app or touchscreen solutions, that's where RISC-V can excellence, where RISC-V can innovate and thrive. Also in IoT, like microcontroller units, RISC-V can be a good choice, and Andes already has signed up customers like Japanese Renesas for innovating in an application-specific microcontroller unit, but also others like Tielink who put it in audio and wearables. Another thing where AI is really driving is in the where RISC-V is driving is in the AI field. So here, Andes sees custom in the data center, but also cloud solution architecture and other developers who are using really high-end cores. Of course, 5G is a new technology. 5G is still adapting, changing the new standards, and bring a new architecture needs in the form of custom instructions. Andes already signed up 2 vendors who are driving in this environment, HQ and also Picocom. You can find more information on the internet, as both have disclosed some of their architecture and why RISC-V is the best. Last but not least, we also see an adoption in fields like storage. Storage has been very stable, but RISC-V can play big benefits by power consumption and again with custom instruction, making it more efficiency or allow on-the-fly encryption and other things like that. Why RISC-V and how can it help? How can it be the solution for your data path acceleration? Actually, RISC-V is offering a variety of fields here. The first one is the RISC-V extension, also called PACT, SIMD, or DSP extension. It adds integer fixed point and is operating on an already existing general purpose register, making the implementation relatively small and easy. The RISC-V extension you would normally use for audio, voice, small image, or slow video application. Next, we can talk about the RISC-V vector extension. Here you're having scalable vector registers introduced. This is really for high data rate computations like you would find in accelerators for data centers, but also in other things where you have AI-related tasks and you need to have a high data throughput. And last but not least, RISC-V is also offering the custom extensions. That's where Andes Technology is offering Andes Custom Extensions, short ACE. Andes Custom Extension is actually a framework. It has the tool called Copilot, and what Copilot does, it takes the inputs like attributes or a Verilog code for your custom extension and then generate the extended RTL, bind it with the CPU core, and does the same for the instruction set simulator and the tools. So it makes the integration or the creation of custom extensions extremely fast and extremely easy for the developer. So you can concentrate on developing your extensions and the Andes tools will help you. Last but not least, there's also an instruction set simulator, and Andes is offering a near cycle accurate simulator, and we have partners like Imperas who also have a fast simulator. So you see you have from the RISC-V extension, which is very small and lightweight but powerful for audio voice, over the RISC-V vector for data centers or 5G, up to the complete custom instruction, a variety you can use. Last but not least, coming back to the RISC-V, look at all these vendors who are already developing RISC-V and working. That is your guarantee that RISC-V will be a future-proof investment. And Andes is one of the driving founders of the RISC-V Foundation and making sure that this is really an industrial usable use with all our other partners in the RISC-V Foundation. Let me give you some short overview about Andes, who we are. First, Andes is a pure-play CPU IP vendor, so Andes is only focusing on developing the latest and greatest CPU IP technology. We are also a RISC-V founding premier member. And last but not least, we are a major open source contributor and maintainer. Andes is a 15-year-old public company, and here we are traded on the stock exchange in Taiwan, so you can check us out with our ticker symbol 6533. Andes is also running various task groups. We have a RISC-V ambassador, and our CEO is also the director of the board in RISC-V. Some quick facts. We are 16 years in business, delivering leading CPU IP. The majority of our employees working in R&D. We have over 200 commercial licenses worldwide. Our shipping base is over 7 billion SoCs shipped, and our headquarters is in Taiwan, but we have local sales reps in Japan to bridge the language barrier and also give local support. If we have a look on our roadmap, our currently available roadmap is starting with a small N22. It's a two-stage pipeline. Worst case in TSMC 28 nanometer HPC plus is 700 megahertz. Followed by this is our 25 series. From the left side, we have an embedded controller going over adding data processing capabilities to having an MMU for running an embedded Linux or something, up to the end where we have application processing with multicore and SMP Linux support. The 25 series is a 5-stage pipeline, worst case 1.1 gigahertz. The 27 series is based on the 25 series, but has enhancements in the cache access and local memory access, so making the overall feeling of your operating system much faster. Last but not least, we have our 45 series. The 45 series is a dual issue superscalar concept, and it's again coming from the embedded control over data processing to the application processing. In the data processing, that's where we think is a strong field. We also have a specialty. It's our NX27V, a 5-stage CPU with a vector processing unit. The vector processing unit is custom configurable to be 512-bit in data wide, 256-byte, or 128. Of course, there is also multi-processing cores for the 45 series, and on the 27 series, we have a single core with L2 cache. Let's have a look on the 27 series with L2 cache. The 27 series has an L2 controller. It is using the standard RISC-V baseline like the G, the C, and the N, plus the P extension, and it has an MMU support for running Linux. It's a 5-stage single-issue core with programmable PMP and PMA, physical memory protection and physical memory attribute, for giving more security in your overall system. The memory boost for the L1 caches will skip unnecessary writes to decache, allow multiple outstanding data access, and enhance the instruction data cache prefetch to give an overall faster serve for memory boost access for the CPU. If you're looking on the L2 controller, let me highlight some of the features. The L2 controller can be up to 2 megabyte with 64-bit lines. We have a 16-way pseudo-random replacement. We are supporting 2 DEC, tech and data banks with bank interleaving, and of course programmable SRAM latencies. Then there is prefetching based on the access types. That means you can prioritize instruction for data or the other way around. And the connectivity is made by a 128-bit AXI master port through the bus interface unit. There's optional also ECC error protection available. Interesting is if we are comparing the L2 cache with the version without L2 cache, we can see that the L2 cache enhances the memory bandwidth by 2.1 times, reduces the memory latency by 30%, and if you're running on spec in 2K on it, you will have a 1.9 times higher performance improvement. So that's showing you that the L2 cache really has a booster and is bringing much needed performance. Next is our 45 series. The 45 series is available in 4 different groups. We have the base group, we have a group with the P extension, and then we have the group with the MMU, and of course a multi-core group. The 45 series is 8-stage in-order dual issue. It independently pairs instruction with 1 or 2 ALLO instruction, and most dependent pairs with 2 ALLO instruction will execute it immediately. There are also late ALLOs for 0-cycle load use penalty. We're supporting unaligned data access. There's a low power dynamic branch prediction machine inside, and it also features the same memory boost subsystem as I have explained previously. The virtual memory support, I just want to highlight, we are having different page sizes and virtual memory mappings from 32 up to 48, and our shared TLB memory is ranging from 32 up to 512 entries, custom configurable. The physical memory support, as I mentioned before, is up to 16 entries, PMP or PMA, and the L1 instruction or data caches can be also configured up to 64 kilobyte. We're also supporting some cache lock support in case you want to run some real-time operating system. And of course, there is ECC or parity protection. There are also some local memories available, which can keep often used memory routines, and these local memories are extremely flexible. They can be, if configured to be available, can range from 4 kilobyte up to 16 megabyte. Like I said, the 45 multiprocessor system is a cache-coherent multicore. Here we are having a MESI-based cache coherence protocol. It is directory-based for scalability. At the moment, we are supporting 1 to 4 cores, and we're planning to have more cores in the future. The L2 cache controller is optional, and the performance will be similar to that of the A27L2 I have introduced previously here. The bus interface has memory and MMIO ports. There are local memory slave ports, so you can preload your local memories with certain subroutines you want to run. And of course, the system comes with an integrated platform-level interrupt controller, debug and trace support, and it is Linux SMP ready. If we look on the performance, you can see that the 45 series compared to this 27 series almost brings double the performance. When I say almost, we can see that we have 70% higher performance than the 25 series, and the whole thing is achieved with less than 50% increase in logic and power area, which is actually quite good result. The memory bandwidth, we have measured this with a C copy function, is 35% higher than in the 27 series. So you can see our memory boost function really has improved too. The 45 series can run up to 2.4 gigahertz at a TSMC 12 nanometer process in a best condition. Last but not least, I want to give a more overview about our vector processor. The vector processor is based on the 27 series I've introduced before, and it's included with the vector processing unit. What I want to highlight here is in the block diagram, the green ways how to load data into the processing unit. Of course, this can work through the data cache or through the bus interface unit, and then the vector processor unit shares the same bus interface like the AXI or the D cache with the 27 series. That can be for some calculation very beneficial and is the standard way of doing it. However, Andes has introduced the streaming port. Streaming port is a second port, and it allows for higher data throughput and loading more faster data into the vector processor. Let me demonstrate this in the next following slides. Here in this slide, we are first seeing how the architecture of the vector processors. So you have your scalar core on the top with the fetch, decode, execute, memory, and retire stages. And then you can see after the decode stage, if a vector interface or a vector instruction is detected, it will be forwarded on the vector processing unit. Here we have a vector instruction queue, and the vector instruction queue will then take the vector instruction and forward it on the different vector units inside the vector processor. So that means that most vector instructions can operate in parallel and also out of order, and the vector instructions or results are also chainable and most fully pipelined. Now let's come to the loading of the data, our streaming port. The streaming port, for example, can be a usage example. that you connect a hardware engine or a smart memory, which has their own SRAM or memory, and then the vector processor can exchange data directly with the hardware engine. This is controlled over the streaming port, which actually is a custom instruction. So you can adjust this to your needs. So that means you could, for example, make this to exchange with a hardware engine, like application-specific DMA, or for some structured computations, like in a convolutional neural network. And you also can adjust it if you have different needs. The advantages is that you have the hardware engine tightly coupled, and the data access is more efficiency. You can use things like address auto-increment or wrap around on memory borders. And one more point is that because having a dedicated memory port, you still can use the scalar core and are not overloading the memory access. The interesting thing, or architecture-wise, the interesting thing what you can do, you can take the vector processor, you can use it with the streaming port and combine it with the hardware engine, which is doing all the number crunching, and this helps you to create a processing element, PE. Now you can take several processing elements and combine them on a bus for it and feed them with a common L2 cache. Then having this kind of building block, you can have several building blocks and combine it in a big system where you also may have an L3 cache, and you can control it with another like our 45 series, which is dispatching the jobs or the workloads to the PEs. There is also programming support undergoing. We're working on this right now, and in future we will have support for OpenCL. So it will be because OpenCL is popular for heterogeneous multi-core architecture with host and devices. And we also will support the RISC-V vector intrinsic programming in addition to the auto-vectorization. Last but not least, we also have seen that the security is more and more important in today's work. So Andes is working or making a framework, we call it Andes Sentry, and it's an open framework for a wide spectrum of threat mitigations to tackle from cyber attacks to physical attacks. It is flexible, scalable, and trustable. This is not only from Andes. Andes is co-working with a lot of our partners, like you're seeing Rambus, Hex5, but also Silex Inside, Secure IC, Intrinsic ID, a lot of partners coming together and building this. The scope for it is to have a TE, to have the crypto acceleration, to have the right protection against cyber attacks, and to be able to provide countermeasures for physical attacks. So as you can see, it's not only on the hardware side, so there's also some software side included. And we think here in Andes that together with our partners, we have a great and secure offering, giving you a faster solution with a very secure environment. That brings me to the end of my presentation. Let me wrap up. The lineup of Andes RISC-V processors ranges from very small power-saving microcontrollers over the 45 series to very powerful vector units. Andes can offer from a single core to multiprocessor with L1 cache, I/O coherence, and L2 cache. I have introduced you our A27L2 and the A45 multiprocessor core, as well as the vector processor and our security framework. Here in Andes, we hope to become your trusted partner. With over 7 billion cores shipped by our partners and 16 years in business as a public company, we really understand what the industry needs and how we can help you. Having local support in Japan is very important for you, and we can help you here with different partners. Let us know. Thank you very much for listening, and I hope to see and hear you soon. Arigatou gozaimasu.